everyone. Welcome you all to TechGig webinar series, our endeavor to empower techies. Thank you for joining the session today. We expect this webinar to last for about an hour with approximately 45 minutes of presentation and the remaining time for a Q&A round. So during the presentation, if you have any questions, please go ahead and send them using Questions tab on your GoToWebinar control panel. Today's webinar is on how to architect a big data application to unleash its full potential. Our guest speaker today is Raghavan Soliam. He is lead architect big data at OSS Cube Solutions Limited. Raghavan has over 17 years of experience in the IT industry across technology, process, and management. He is currently associated with OSS Cube and has delivered critical and strategic IT solutions to clients in multiple industries with deeper experience in the insurance and finance industry. Data has always been his major interest. He has very strong background in databases, data modeling, and data warehousing. He is a Cloudera certified trainer for developer and administrator classes and has conducted several trainings and consulting assignments. In the Hadoop stack, Raghavan has experience in Hive, Fig, Flume, Scoop, administration, and HBase. He is also familiar with NoSQL technologies such as MongoDB, and he is currently pursuing further learning in machine learning and data science. So without further delay, I introduce you all to our guest speaker. Over to you, Raghavan.
Yeah, thanks, Deepika. You can hear me, right?
Yes, sure, we can. Thank you.
Hello. Yeah, thank you. Yeah. So good afternoon, everyone. First of all, it's a pleasure having you all on this webinar. Today's webinar is about architecting big data applications. I'm going to explain why this topic was chosen and what is the purpose behind it. So first of all, I'm Raghavan Soliam. I work for a company called as OSS Cube Solutions. It's a firm specialized in developing the solutions using open source technologies. And also we contribute tremendously to the open source the tools out there. So that's briefly about my company. And about myself, so as Deepika explained, I have over 18 years of experience with vast experience in the industry in various areas and currently focusing on big data technologies. So at OSS Cube, I work as the lead architect big data. I take care of the consulting assignments for the big data related problems as well as the training. So we are in fact the partner with Cloudera for providing the Cloudera based trainings. So today's topic, the big data architectures. So rather, we can call it as the Hadoop architectures. Today, we don't have many big data implementations without having Hadoop. Right. This topic is very important today with the rapid changes that are happening in the big data domain in terms of the range of the tools that we have out there, and then the rapid enterprise adoption that is happening. So if you see the adoption rate in 2010, if you see, there are very few companies which had the production deployment of the Hadoop. But today, if you see, there are a lot of the companies either in POC stage or moving from POC to production, right? So there are several companies. Everybody is going and implementing a big data solution so that they don't fall behind. And a lot of the enterprises also started seeing value out of the big data, solutions. Right, and talking about the purpose of this training, as I said, there is a vast number of tools available, and with the duplicates. In fact, if you talk about the Kafka, Flume, and then Storm, so there's a lot of overlap of functionality between these tools. And several times, as a novice or beginner of the big data technology, you may not be able to decide which one is the best. right? And there is not enough documentation out there, not enough books out there. So we thought we will touch upon this topic so that people will start thinking, and then they will be able to think in the right direction for architecting their big data applications, right? Yeah. So there are some prerequisites that are expected for today's webinar. As I said, it is about architecting the big data applications, because we expect, because of that, we expect the participants to be aware of the big data and Hadoop as well. So it will tremendously help if you already have some knowledge about it, right? Otherwise, some of the things you may not be able to grasp, but maybe you can take it as an opportunity to note down various items that we are talking about, and maybe afterwards you can use for your own research and learning purposes. Right, it's very useful for the architects because they'll be working on the solutions for their customers, and then pre-sales it's very useful because they will be selling the solutions to their customer. What are the right things to implement, how to integrate. All this information is going to be very useful for pre-sales professionals as well. So today's agenda is goes like this. We will discuss about the purpose of this. I briefly explained. Once again, I will do a slightly deep dive into this, and then we will discuss how does a big data application looks like, what parts it has, what fits where. Right. So this is what we're going to discuss today in depth. And considerations for architecture, what are the various things that you have to consider when you're architecting, choosing the products for your big data solution, and what are the various options that are available in the big data suite, and then which fits where also we will discuss. We'll also discuss on two sample architectures where we will see the fitment of various tools and products that the big data has. So that will give you an idea about where the fitment of various tools in the workflow of a big data application. Right. So finally, we will have some time left for question and answers, around the 15 minutes. Yeah. So I think that's fine with all of you. So first of all, I would like to say that the topic that we have chosen today, the big data architecture, the best practices, or however we want to call it, as how to engineer the big data applications. Right? It's a vast topic, and if we start discussing, it can go on for a couple of the weeks, because it is so vast. You can talk about architecture of various tools, the integrational aspects of the various tools, right? But I tried my best to fit this into this 45 minutes presentation, right? So we'll not be able to get into the depth of each and every the topic. I tried giving a bird's eye view of a big data architecture with this presentation, so that we can start here and go along this path to learn more and get into the depth of the big data architectures. Right. So in future webinars, I also plan to do some deep dive into specific use cases and specific architectures, so that we will have this continuous learning. But here in this webinar, you can take out a bird's eye view of the big data architectures. Yeah. Okay. So first, let's look at a big data application. Right, so a big data application is just not Hadoop, right? You have a Hadoop installation, put some data, and then you start writing some MapReduce programs or Spark programs. That will not suffice the need, right? So big data applications typically are built for analyzing the data. Right, it could be real-time data, or it could be the data that is stored on your storage system, and then some analytical queries are executed on it, either through some machine learning algorithms or through the BI tools. Right. So if you look at a big data application, structure or the flow, you typically will have the multiple data sources. right? So when I say data sources here, you will have multiple data sources. You may have the operational data sources that your enterprise has. You may be interested in some file-related data. File-related data typically you will have in case you have legacy systems, in case you do not have integration, or your vendor or third party is providing the data. So that could be another source of the data for your big data application. Right? This data first needs to be ingested. So you need to bring out the data, extract the data, and then put it on your storage system. So a big data application also has the storage system. So where you will store the data, and then later you try to process, or in real time also you can process. Right? So coming to processing, you have two kinds of the processing that you can do that you may be interested to do in a big data application. Right? You may want to the process in real time. For example, there are a lot of use cases out there. Fraud detection, monitoring of the services, right? So these kind of things, they need the real-time attention as the events are created. As a fraud happens at an ATM, fraud happens when someone swipes his credit card, you want to capture that event and then see whether it fits into a fraudulent transaction and respond immediately. Right? So this hardly will have few seconds of the time to respond. Right? So here the question is, why can't you do that with a simple application running on a single server? Right? So when you have a lot of data, flowing into your system and it needs to be processed and responded in real time, a single server may not be able to scale. So that is the reason in some cases when you have to process the real-time data, respond in real time, then you need a distributed application like the Hadoop. Right? And the second way of the processing the data is batch-oriented data. Right? Some of you must have done the ETL process, extract, transform, and load. Right? The data will be used later on for further processing and exploration purposes. So in a batch mode, you have to store it on a storage system, right? And then the data that is stored on the storage system will need to be cleaned and needs to be processed, for example, to eliminate the duplicates or to convert some codes, right? And then remove unnecessary fields. So a lot of things that needs to be done before you actually go and process the data. So once you process and you have this clean and usable data, you may want to use it differently. For example, you may want to randomly read the data. Or you may want to sequentially access. For example, you are aggregating your data, then you may have to do a sequential access. Or you want to just say that you just want to access one record out of 1 million records, right, based on a key. So then you may need to store it differently, right? Or you want to query using SQL. You want to query using SQL, there are a lot of other options, right? So based on that, you have to store your data into different storage options. So from where you will be able to do the relevant processing. For example, you can, if you store it in a NoSQL store, you will be able to, access using NoSQL tools. Right? And then BA and visualization, you have data stored in one of the options like Impala or Hive. You will be able to use ODBC, JDBC kind of connectivity to do BI and visualization. Right? So similarly, there are other options as well in the big data world. So based on your preferences, you will store in different storage options, which finally can be queried and processed by the respective tools. Right? So this is at a very high level. So again, I don't say that this is the only architecture that is possible in big data and Hadoop world. I would say no. So there are several parts and options that are available. But at a very high level, if you see, this is what you do in a big data application. You ingest the data, store it, sometimes you stream process it, sometimes you do some ETL, which cleans and stores the data in different storage options. This is where the data becomes useful. You can query to get some intelligence and then generate some alerts and all those sort of things you can do, right? So with this background of how a big data application looks, so let us get into further details. I, in fact, purposefully avoided naming the tools and products here, just to give a generic view of how a big data application looks like. Yeah. It is just not Hadoop, right? Hadoop is not going to solve and provide solutions for each of these stage. But fortunately, in under Hadoop umbrella, you have a lot of the tools that can help you with each of this stage. And in fact, I will say that it's not only Hadoop, but you also sometimes find the tools outside the Hadoop umbrella will be very useful. So I will try to name some of these tools in our discussion. Yeah. So talking about the ingestion, you have several options, right? Scoop, Flume you have, and then you can also do ingestion using some of the commercial tools like Talent, Informatica, and Kafka is another option for ingestion, right? So these are suitable for different cases. So different scenarios you have, you can go for one of these tools, and sometimes combination of these tools based on their strengths and weaknesses. Right. So we'll discuss to further depth how do you choose the ingestion tool, whether you go for Scoop, Flume, or some other tool. Right. We'll have some more a little bit more detailed discussion on that. So that's about ingestion. So coming to the storage system, right? So we have been, I think most of you must be hearing about the HDFS, right? But HDFS is not only the storage media that is available out there for the big data technology, right? HBase is another option, but HBase relies once again on the HDFS, but the data ingestion and the retrieval happens to the HBase interface. So HBase is considered as another option for storing and retrieval of the data, right? And of course, there are other file systems that Hadoop can work with, like GlusterFS is another file system, and then Isilon of the EMC, Isilon 1FS is another file system. So these are commercial, some of them are commercial, they're not frequently used, but HBase is one of the popular files, most popular file system I can say in the Hadoop world. So HBase is a case basis the storage mechanism that is available out there. Right, and then so once you store the data, you may want to process this data in real time, right? So real time again is very subjective. It is misused many of the times, right? So so this real time has several definitions. It can is it minutes, is it seconds, or is it sub-seconds, right? So depending on this, you have several options. For example, if you want to process your data in near real time, you have Spark streaming is one of the option, and then you have the Flume with Spark based processing or MapReduce based processing is another option. Right, but it is not really real time. But if you want to process your data in real time, then HBase could be one of the option. HBase is you can call it as Hadoop database, which supports millions, literally millions of reads and writes. It's a distributed database which can support millions of reads and writes, using in the Hadoop environment. Right. Of course, there are other options. Again, I would like to stress that these are not the only tools and options that are there. There are a lot of options. For example, for real time, we frequently use Kafka with the combination of the other the data processing options. Yeah. And for generic data processing, right, you have the data out there. You are okay to store the data. You are not in a hurry. You can process the data over a day or over a week, right? Based on how your interface of the functions, what kind of SLAs you have, right? So you have several options out there. Spark is one of the options, Core Spark, which processes the data in a batch mode. MapReduce is actually dying out. I don't say it's dying out. It is less frequently used. Most of the new developments are happening in Spark today, less in the MapReduce. And there are other options for data processing using a higher level abstraction, in the sense you don't like the Java, or you don't want to learn Java, but you are already an expert in SQL or some scripting language. You can still process the data that is sitting in Hadoop by using the Hive, Pig, Impala, right? Spark also supports SQL. You can write your data processing in SQL using Spark, right? So these are the options for generic data processing, and there are various processing frameworks for the special data processing. For example, you want to do machine learning. So I'm sure that some of you must have read or did machine learning, right? So you have some libraries that are out there in the Hadoop MapReduce, which runs on top of Hadoop MapReduce, which runs on top of the core Spark. For example, Mahout is one such framework which can do machine learning on the MapReduce, Hadoop MapReduce. So similarly on Spark, we have MLlib, machine learning library, and then GraphX is for processing graph-oriented data. And then Spark R is for processing either machine learning, or Spark R is basically a language, statistical processing language, right? So now it is integrated with the Spark so that you can develop analytical, statistical processing programs using the Spark R, right? So that is another option for the processing your data. And there is other thing that you have to consider is the storage format. How are you going to store the data in your the HDFS? Because storage format is very important because of several aspects. One is the storage itself. If you compress a file, you'll be able to save a lot of the data, right? If you serialization is another aspect. So basically, it's a distributed processing environment, and data very frequently needs to be transferred between the nodes. Right? When you have to transfer the data between the nodes, send it outside the machine, or let's say you want to write it to the disk, you need to convert your the objects into a series of the bytes, right? So serialization is such process, right? So because this results in the data that is being written to the disk or being sent outside, sent on the network, the efficient the serialization is going to be, your program is also going to be efficient and performant, right? So there is another format that you must have heard, that is very popular nowadays, is columnar data format, right? So the difference between the traditional storage, which is a row-based storage, which all our RDBMSs follow, and the columnar database is that in columnar the columns data is stored together, but whereas in row-based, the rows are stored independently with all its constituent fields. Right? So the columnar format is more efficient for certain kind of access patterns. So choosing the right storage format is also very, very critical for building efficient architectures and the performing applications. And BI and visualization, so that probably is one of the desired end product of all this, the initial steps that we are doing, ingesting, processing, cleaning, and all that, right? So this is where the rubber meets the road, right? The management can see the data in action. So you want to visualize, or you want to create some models using the machine learning and all that, right? So you can do this using one of these options, Hive, Impala, right? Using JDBC, ODBC connectivity, you'll be able to directly launch your BA tools on top of the data that is sitting in your Hadoop. But the challenge here is we have so many tools, right? As I said, I have not listed all the tools here. but still we have named so many tools out there. So the challenge is, how do you choose the right tools? What ingestion tool you're going to use? What platform you're going to use for processing your data, right? Whether you're going to use the Spot, MapReduce, or the MLLeap, right? Or some other different framework. How are you going to choose, right? Storage format. What is the suitable storage format? So how do you make a decision about it? Okay. So there are certain considerations that you have to take when you are architecting your big data application. Right. Some of the questions, again, I will go ahead and say that these questions are not limited to only these points. You can ask more questions based on your use case, based on understanding of your environment and the specific tool. But in general, these are some of the questions that you have to ask yourself, right? So what kind of data sources are you dealing with, right? Are you dealing with RDBMSs, right? Are you dealing with the files? Or you are dealing with events, log events, or some transactional events, or you're dealing with the streams like Twitter, or a port which is sending the data out. Right. So what is the kind of source that you are dealing with? Right. So that is one of the consideration that you have to take. And timeliness of the data ingestion. So how soon you want the data generated at source here in the processing system, right? Is 1 minute okay? Is 30 seconds okay? Or is it okay to have it after 1 hour? Right? It depends, on your use case. For example, if it is a fraud detection, you want the data as soon as possible. Right? At the earliest you want, so that you can detect the fraud, and then you will be able to send an alert or suspend the transaction. Right? So it depends on the timeliness of data ingestion. Right? If it is, let's say that it is, it does not really matter, by evening you want the data, then you can use a different kind of ingestion technique. And second thing, do you need real-time or batch processing? Right? So do you want to process the data immediately, or you want to process the data in batch? Maybe you want to accumulate the data for over 1 hour, and then you want to process the data at the end of the day. Right? So this can decide what kind of the processing framework that you want to choose, whether you want to go for real-time processing, or you want to you can go for the batch processing mode if you're not concerned about immediate result. So that is another aspect that you have to keep in mind. Yeah. And how are you going to access the data? Do you want to, after storing the data, you are okay to access the data in a sequential manner, or you want to access the random, the way, right? So I hope you understand the difference between these two. Just for understanding, you have, let's say, a billion record, and you want to get specifically a specific record or a few records with a given condition. So that's random access. Whereas sequential access, it will not, you have to go through each and every record to come to a specific record, right? Here, the objective is not to get a single record, but you want to do some computations on entire set of records, right? That is where sequential access is going to be useful. So how are you going to access your data is also an important question while architecting your big data application. So what kind of processing you want to do on your data? You want to create the predictive models, or you want to run some ad hoc reports or BI related queries that you want to run, right? So what kind of processing that you want to do? So that will help you decide any storage layer that you want to use, for example, Impala or Hive, right? Or you want to use any specialty frameworks like MLLeap, kind of the choices, right? So that is one of the aspects that you have to keep in mind. Latency expectation, right? So this latency expectation is different from the timeliness of data ingestion, right? So latency here, what I mean is that, let's say that you're running a query, right? Is it okay if I return the result of the query in, let's say, 10 minutes? Or do you need immediately, right? Like a couple of seconds, or at maximum, 1 minute, 2 minutes, right? So if you look at the Impala, I'm sure that you must have, read about Impala. So the data that is sitting in Impala is historical data, right? It is not really coming in real time. But when you run a query on Impala, you expect the result to come fast, right, in a few seconds to a couple of the minutes. So that is the latency expectation. So you want low latency queries, then you probably have to go for a different tool. Right? So other thing is the access pattern, right? How are you going to access the data? Do you need the entire the record for every transaction that you're processing, or is it okay? You are just concerned about let's say a few fields, not all 1,000 or 2,000 fields that are stored in your HDFS, right? Access pattern is also very important in choosing the right storage format and the right storage system. Right, so these are some of the queries that you have to ask while architecting your applications, because all of these things are going to impact the overall performance of your big data application as a whole. Right. So now let us get into the details of each of these stage. Like we talked about ingestion, storage system, storage formats, and then just discuss various scenarios, and then see which suits which specific use case and scenario. Right. So data sources, right? Today the world is full of the data sources. Earlier we used to have only database, but everything is a source today, right? Even I think your body might become a source, your head might become a source, right? A tree might become a source, right? We are, we already entered the realm of the IoT, Internet of the Things. Everything generates data, and you're interested in capturing it and processing it and getting the intelligence out of it, right? So there are several data sources. I have represented some data sources here. Operational systems, typically it's an RDBMS that we use, and then server logs. Log analytics is very popular today, and a lot of insights like recommendations and then user behavior, all these things, and even the events, right? Server is down due to some reasons, an exception is thrown. All this kind of information is stored in the logs, either web logs or server logs, which are useful in analyzing the performance of your servers, behavior of your users, right? So server logs, and sometimes files in case your integration is not possible, and some third-party vendor is providing a third party is providing the data, right? And then you have a lot of streaming sources today. You are doing something on your mobile. The data is streamed and streamed to the server. And this needs to be processed. For example, you keep getting this mobile ads nowadays, right? So that is done in real time. Your actions are streamed to a server. That server analyzes what you're doing, and then relevant advertisements are pushed to your the screen. Right. So we have a lot of streaming sources coming from telephone towers, coming from your factories, or coming from what you are watching on your TV. Right. So a lot of things are Internet of Things streaming the data. So a lot of data sources are there. So based on that, you want to ingest the data into your system, your big data system. Right. So for ingestion, we have several options out there. Scoop is one of the options, Flume, Kafka, and even ETL tools such as Talend and then Informatica are also integrated with your big data solutions, or Hadoop in specific, right? So that you can ingest the data into your the big data system, right? For example, Scoop. Scoop is suitable for the RDBMS. Or sometimes we say it as structural data, but it is we can say it is not RDBMS, right? It can extract data from an RDBMS and then store it in a storage system. So typically HDFS or HPs, right? It can put the data into both these stores, right? And then Flume and Kafka. Flume and Kafka are suitable in case you have streaming sources, or sometimes you yourself can create a streaming source. The purpose here is that transporting the events in real time. Right, you have a log message generated on your server log. You want to immediately get this log message and then ingest into your the Hadoop cluster, and then process it and do something. right? So Flume and Kafka are for real-time event transportation, right? So you can typically the real-time events are put into a stream processing if it needs to be processed immediately, or you can choose to put into either the permanent storage like HDFS, or you can actually transport this event to the multiple systems as well. Like same event can be stored into the HDFS, and maybe it can be transported to a stream processing engine, right, where it can actually process this event and generate relevant alerts or monitoring of the servers. Right, or real-time visualizations, like you have a tool called as Graphite, where you can actually plot the behavior in real time. Yeah. So what are the considerations? How do you choose? Right. What is the source system? Right. What is the source system? If it's RDBMS, go for the scoop, or if you have an ETL tool, you can go for, in case you have heavy transformations that are going on, you can go for the ETL, where you can you can process the data. You can transform so you can do some transformations when the data is in the flight. Right, timeliness of the data. Do you want the data immediately? Then either use Flume or Kafka, which can pick up the event in real time and then send it to your into one of the processing systems. Failures or fault tolerances, right? So from the batch oriented to real time, we are clear. Batch, you go for either a commercial ETL tool or Scoop, or if it is real time processing, then Flume and Kafka. But when you choose between Flume and Kafka, right, Flume can be used in case you are not much worried about the failure, right? So Flume is, though it is distributed system, but it has less fault tolerance. The fault tolerance is built into each of the agent. So where if that fails, you have the tendency to lose the data. But whereas Kafka is a distributed system, distributed and fault tolerant, right? It also replicates the events so that it is even if one of the node comes down, the events are retained, right? And then it can the consumers can pick up the data anytime that they want, right? So Flume is Flume is more like a push-based systems. It gets the data and then it gives the data to the consumers. But whereas the Kafka is known as pub subsystem, publisher subscriber system, where the publishers can put the data into the Kafka queue, and then the consumers can get the data from the same Kafka queue. So thereby it disconnects. It makes the queue, Kafka queue, independent of who is publishing the data and who is consuming the data. So these are some considerations that you can take while choosing your ingestion mechanism. Okay, so that is about the ingestion, but again, I'm just giving you a broad eye view, like I mentioned. So there are much more details that, if you're interested, you can refer to either the documentation or the respective books. Yeah. So that's about ingestion. Storage systems. Most of the people know only HDFS has the storage mechanism of the big data world or Hadoop world, but there are a lot of other options which sometimes not considered as the storage options. HBase. It works on top of the HDFS, but the data is operated through the HBase interface, HBase API. Right. So what are the considerations here, right? So do you want random or sequential access? So if you want random access, HBase is a better option. So if you want sequential access, then HDFS is better. But if you want the SQL-based access, in the sense you want to process your data, by writing a SQL, right? In which case you have to create not only the data, but you also have to create the metadata. Right. So Hive and Impala, they support a metastore where you can create the metadata about your data. Thereby, it allows you to process the data using the SQL. Right. So these are various storage options that you have. and how do you choose, right? Random access, HBase, and then sequential access, HDFS is a better option, and then you want to process through SQL, then Hive or the Impala. But of course, Hive or Impala, once again, it relies on the HBase and the Metastore, right? So I have intentionally have put dotted lines again against the Hive and Impala because these are not typically, they don't have their own file systems. So that's about the storage system and real-time processing. As the data is coming, you want to the process the data, right? So if you want to, if you have such requirement, there are multiple options in the Hadoop world. You have the Spark streaming, so and then Storm. So how do you choose between these two? So if you latency, right? If latency again can be defined in minutes, seconds, or sub-seconds, right? So again, like the near real time or real time is what here we are referring to, right? So if your response time is near real time, which means it is in terms of the seconds up to minutes, up to a minute. So you can use the Spark streaming. But if you want instantaneous response, sub-second response, then Storm is the right option for you. Again, the streaming needs to be done using streaming options, either Flume or Kafka. Again, if it is a near real time, then real time, then you will go for the Kafka. Or if it is not so real time, in the sense if it is near real time, then you might go for the Flume. Yeah, so that's about real-time processing. And coming to the processing, right? You have enormous options here. So this is where actually the big data world of the Hadoop started and evolved. Earlier we had only MapReduce. Now we have the Spark. On top of these other layers, abstraction layers, or other useful frameworks were built to do specific processing. Right? What are the considerations that you have to take to choose the processing environment, right? So, so what is the latency in the first place, right? So hours, is it hours or minutes or seconds, right? And the kind of processing that you want to do. You want to do any specialty processing. What is the kind of skill set that you have? Your team knows, let's say, SQL well or Java well. So then, or Python well, then accordingly you can choose your framework. For example, if you want to go with SQL, then you have options on MapReduce. You have Hive, and you have Hive on Spark, which is a little recent, and you also have Spark SQL. You want to do the machine learning, then you can go for MLA, graph-oriented process, GraphX. So you can, based on the kind of specialty processing that you're doing, and then the kind of the skill set that you have, you can choose what is the framework that you want to process your data with. Right? So that's about processing. Storage format is another important aspect, as I discussed. There are a lot of storage formats that you must have heard in Hadoop. You can store the data as a plain text file, as a sequence file, or as an Avro file, Parquet file. So different options have different advantages. For example, the considerations behind the file format or storage format is splittability of the data. Is it okay to split your data? For example, you have XML data. You split XML data across your distributed system, then it will become difficult to the process. Right? In such cases, you may want to go for a container format, such as sequence file or Avro file. Access patterns, right? Are you going to access all fields or some fields? Right, so based on that, you can go for columnar format or row-oriented storage formats. Compression is other thing I just explained in our first slide. How compression can improve your performance. Serialization is another aspect. Right? How do you serialize? You choose a better serialization. The data transfer between the nodes will be very, very efficient. Whether you're going to store the data long-term or short-term, that is another aspect that you have to keep in mind. And interoperability is another aspect that you have to keep in mind. The data that is generated in one system needs to be used on other system, right? So in such cases, you also have to choose a file format which is interoperable, right? So these are some of the considerations that you have to take. Plain text is a big no-no. It occupies a lot of space. and then it does not support any specific access patterns. Sequence file, it stores binary data, so thereby the programs can easily convert the data into the objects and start processing immediately, so it improves performance tremendously, right? But there are some issues with the sequence file that it is not, its interoperability is low. So that is where Avro file has come into picture. Avro file is interoperable between various languages, various frameworks, and it also stores a schema with the file. Thereby, it becomes evolutionary in the sense, as the time passes, the various systems will be able to share the data. Parquet file is another popular format today. It is a columnar format, which also stores the schema, but it stores the data in the columnar format, so which will be useful in case you are accessing your data sparsely. So these are the considerations and the options that you have for storage formats. Okay, so again, like I said, these are some of the high-level considerations. So as you start working on a use case, sometimes you may have to go a little bit deeper into the aspects, but it is a very high-level aspect of the consideration that you have to take while architecting a big data application. So now I would like to take a couple of examples and explain how the various options were chosen here. So here I have taken, I tried explaining the options for near real-time the processing, the fraud detection in credit cards, right? So when in fraud detection, typically what happens is the transaction is mapped into one of into fraudulent or non-fraudulent case, right? So here, here a person swipes his card, so the transaction will go to a web application, right? So the web application immediately need to access the profile of that user, right? So here we need a real-time access. So we are using HBase here, so because there'll be millions or billions of users, and you need access to this data in real time. So we are using HBase here. So HBase is the storing option here, right? But later, these events also needs to be stored for long-term usage, and then also learn the things from these transactions. So as transactions are being generated, so we can use either Flume or Kafka. Again, it depends on the latency that you're expecting, right? So Flume or Kafka to stream these events to the Spark streaming to process in real time, and then if there are any observations that this streaming process can make, so they can be fed back into the HBase so that any further transactions can use this new insight that Spark is producing. Further, for learning, machine learning or exploratory analysis by analysts later on, we also want to store the data into the HDFS, and then this data basically can be used by the analysts later on using various frameworks. Impala is a good option, Spark SQL is a good option, MLlib is a good option to process this data, right? These learnings can be fed back into HBase for real-time access and processing. Right, so this is one of interesting use case. So the second use case I would like to discuss is data warehouse on the Hadoop. Right, we have several options today. Typically, the way the data warehouse works is ingest the data into the data warehouse and do the transformations actually in between before ingesting into the data warehouse, and the data warehouse will be accessed by various tools, BI, and then the insights are generated. So how do we implement that in the Hadoop environment? Right, you have the operational data, various RDBMSs that you have, various server logs, or many other sources, right? Sorry. So you can use Scoop to put operational data into the HDFS, as well as you can use a Flume to ingest the data from your server logs or various other streaming sources into HDFS, and you can use the big MapReduce programs or Spark to transform your the data. The transformed data can be put into one of these storage options. You can put it in Hive if you want to access it in batch-oriented mode, or if you're okay with slow response. If you want immediate response, you want the results in seconds or maybe a couple of minutes, Impala is one of the options. right? And HDFS, in case you want to do some batch-oriented queries, or sometimes you want to process the data and load into another data warehouse, another database. So you can store it in HDFS, or you can also store the data into HBase. Nowadays, you have another tool called as a Kylene, which can create the cubes for your data that is stored in the HBase. Thereby, you will be able to do the multi-dimensional queries like you do in your enterprise data warehouse. Yep. So, so this is the second use case that I wanted to discuss. But again, as I said, I tried giving a board eye view because we have very limited time here. Maybe in the next webinar we can focus on a specific topic and do a deep dive later on, right? So. That's all we have in the discussion today, and now I can take up the questions. So I will, Deepika.
Thank you, Raghavan. Thanks a lot for this really insightful presentation. We would request you to take up the questions. Those have been assigned to you on the questions tab.
Sure, yeah. So I will take up the relevant questions, some of the interesting questions, because we have very limited time. I will read out the question for the benefit of others, and then I will answer. Right? Okay, so it's not it's a question not very relevant to this, but I will answer because it's interesting. Is there a Hadoop as a service facility in AWS like HD Insight in Azure, right? Yeah, we have a very mature and a very interesting service called as EMR. Using EMR, you can spin Hadoop clusters in the matter of minutes, and hundreds of nodes you can spin off. And also it's quite cheap in the sense you can use it only when you want, and you can bring it down once your processing is done, right? It is on demand. So it is EMR, and you can also create a Hadoop cluster if you want to create your own cluster with your own storage system and the configuration options. You also can create a AWS. You also can create a Hadoop cluster on EC2 as well. Yeah. Yeah, this is a good question. Is Hadoop suitable for transaction the processing? So absolutely not, right? Because transaction basically it needs almost instantaneous response, sub-second response, right? Not even second is acceptable. If you're operating on a website, if you get the page in 10 seconds, you say this site is crap, right? So it is meant for, as you can see in the last two use cases, right? It is meant for analytical processing, right? And sometimes, your RDBMS will not be able to support your transactions. In such cases, you have specialty tools like HBase and all the tools where you can just store the transaction, but it is not a real transaction, right? It has very limited access patterns. It is not going to replace your RDBMS, right? Yes, the answer is a 99%. Yes, you cannot use Hadoop for transactional processing. Okay, so big data applications solutions are more applicable to OLTP, OLAP, or both, right? It's applicable more to analytics, right? So things are going beyond OLTP, OLAP, right? It's more, I will say, OLAP. OLTP is a big no. OLAP is where you denormalize the data, and then sometimes you create cubes to query your the data, right? So it's applicable more for OLAP, but in OLAP you cannot process unstructured data unless you pre-format and fit into some fixed models, right? So so actually Hadoop goes beyond just OLAP. Yeah. Okay, Impala and Hive are used for different purposes, right? Yeah, the answer is not really. It depends on the latency expectation, in the sense when you fire a query, your SQL query, you are expecting your result within seconds, then you have to go for Impala, but there is no option, or there are different options as well. But Hive, you have to expect some latency, right? Because Hive uses MapReduce behind the screens, or Spark. Spark is a latest thing. So you have to expect some latency, right? At maximum, you probably can get minutes of latency. At the best, minutes of latency, right? Sometimes it can go to even 10 minutes like that, right? So, but Hive query language is much more mature compared to the Impala. So that way they are slightly different, but the purpose, the difference is only the latency and the language maturity of the Hive that we have there. Okay, how big data application deviate from traditional applications running on the DBMS, right? So it's a lot different. First of all, the big data applications they're mostly distributed or MPP, massive parallel processing that Teradata does, Netezza does, right? So these are distributed applications, distributed storage plus distributed processing. But whereas traditional applications, they're mostly they will run on a single server or load balancing mode, right? So it's more or less a single server mode. So they're a lot different. Right? So whereas big data applications from data processing perspective, they're much more flexible. They can process unstructured data. Their cost is also pretty low, right? Compared to the data volume that they can process, right? So if the same data that you have to process in a data warehousing environment, it might cost much more, and you will also have a lot of issues, scalability, upgradation. So you'll have plenty of issues, but from the big data architectures, they are pretty flexible, and then you can scale linearly with your data growth. Okay. I will. In the interest of time, I will take maybe 2 more questions, and then other questions I will try to answer through the emails. We'll post the answers later on the forum so that you can access and read. Okay, so the question is about when you're dealing with real-time data, is it processed fast and then it's stored, or other way around, right? So it depends actually. Suppose in case of the fraud detection, you will take 2 paths. You will fork your data, and then one side it might go to the stream processing the block. Other side it might write to the HDFS, right? If you want to store this data long term and do some learning from it, then you may want to store it in the HDFS. Or for example, say that you don't want this data, it's a waste data, right? You just want to process it and get some insight and throw it out, right? Then you don't need to store it all, right? So nowadays you have the streaming systems where you can push the data without writing to any storage media, right? Like HDFS, you don't really need to write, right? For suppose you want the fault tolerance, right? But you do not want to do any learning and all later on. But in such cases, your architecture can consider writing onto a media like HDFS. But most of these streaming systems, they have built-in fault tolerance within them. But you still want to provide more fault tolerance as part of your architecture. You can actually write into the HDFS and then process it using your streaming system. So thereby you have some fault tolerance built into your application layer itself. Yeah, and then okay, other question: if we have 1 million records or over 1 million records to get processed in a day, so what is need and the priority for moving to big data architecture, right? So if you have let's say 1 million records, right? 1 million records, I frankly say it is not much, right? If you just have to process 1 million records, and you don't want a long-term storage. Maybe you want to store it for, let's say, 4 months, 6 months, and your record size is not very big. Your processing, capacity, processing each record is not very hectic. Then yes, there is no real point moving into a big data architecture, right? Big data architecture is pretty complex, and then you need administrators and very skilled developers to develop programs for it. And it's not like the olden days where we learn SQL and then we can lead our career for 10 to 12 years, right? So today, a big data developer needs to know about a number of the tools, right? And then should be able to program in various languages. It's quite complex, right? So if there is no real need, I will not move to a big data architecture, right? It is like you want to plant a seed in your backyard. You can do that using a kitchen spoon, or maybe if you have a bulldozer available freely, you can use a the bulldozer or whatever crane, right? So it does not make sense. So if you do not have that kind of heavy processing, right, I recommend sticking with the traditional systems rather than choosing a big data system, right? You have to see a need to move into big data systems. Yeah. So that's all. So any other questions are there? I will look at them and I will try to answer. So I would like to thank all of you for attending this webinar. It's a great way of collaborating and sharing the knowledge. Right? And we have over 100 participants today, which reflects the agility of the technical open source community, especially. So I would like to thank to all of you, and see you in my next webinar. Yeah. So
thank you so much, Raghavan. Thanks a lot for this really informative webinar today. It was indeed a great session.
Thanks, Deepika.
Yeah, thank you so much. We'd also like to thank all our participants for their support in making this webinar a success. For those of you whose questions have not been answered, we'll request you to post them on TechGig webinar page on the question forum. This session has been recorded and we'll be sending out the link to everyone after the session is over. The recording will also be available on techgig.com on webinar page under the category of webinar calendar. So thank you, Raghavan, again. Thank you, everyone, for joining us.
Thanks, everyone.